You're welcome once again to New Focus Approach to Mathematics Basic 7 Revised Edition. In this lesson, we want to look at the concept of pi. What is pi? We've been hearing about the word pie, not the full pie that we eat, meat pie, no. Talking about the concept of pi, which is being used in mathematics. It's so amazing to know about this. Now, what I want you to do is after watching this video, go search for cylindrical object like Mach 10, Milo 10, any of this kind of thing or any cylindrical object. Now get yourself a tape measure that can help you measure the circumference of this circular object, and then get yourself a ruler that can help you measure the diameter of the following object. Okay, so if I say diameter, I want you to understand that you're looking at the distance between one point on the circumference of a circle to the other point passing through the center, and so your diameter must be well calculated. Then the circumference simply means distance around the object. Good. Now I'm going to use GeoGebra to help you create different types of circles with their circumferences and diameters. So here you can see that I have a circle. When the diameter is 3, circumference is given over there, that is this one. And when I increase diameter to, let's say, 3.8, circumference also increases. So I can generate, in fact, thousands of values for a particular diameter and its corresponding circumference. So for now, we have 2.5, then circumference is this. If we have 2, circumference is that. Okay, now let's try to tabulate few of these values of circumference with respect to their diameter. So when the diameter is 1, there's few records that I have taken. When the diameter is 1, circumference is 3.14. When diameter is 1.2911, circumference is 4.0562, and it goes on and on and on. Now I want you to pick a calculator. Okay, you can pause the video, set for calculator, then get closer again. Divide 3.14 by 1, and you get the value as the same. Divide 4.0562, that is this one, by this. Divide this by this, and you get the value as this on the calculator. Divide this also by this. That means the circumference of a particular circle is this, its diameter is that. When you divide, you get this. And that circumference is this, diameter is this. When you divide, you get this. Now when you continue this division, you realize that you are getting this kind of values. Observe 3.14, 3.141, 3.141. You see 3.141, and it continues. Remember, this is approximated value. This value seems to be consistent, the same throughout, and it becomes like a constant. So if you generate this value maybe in more decimal places, realize that you get some kind of decimals which continues without terminating or repeating. So this value that you see here is a constant, and because a constant, for anytime you pick any circular object and you divide the circumference value over the diameter of the same circular object, you end up getting this kind of value. You understand? And we call this value pi, constant value pi. Okay, so pi is 3.14152592653589793. Oh, that's huge. It's so amazing, and it will continue on and on and on without terminating. And we know from our lesson that anytime we have a number that does not terminate in terms of decimals, that does not repeat also or recur, that number is called an irrational number. It doesn't make sense. If you want to mention this number, you mention it for the next 20 years, you'll not finish mentioning it. So we call it an irrational number. And so pi is an irrational number. Now observe a number called 22/7. That one too, if you put it on a calculator, it will give you a value of this sort. Look at the first 3 digits. 3, 1, 4. And when I approximate this one, I can get 2, so that to be also that. This few digits is equivalent to pi. And so mathematicians realize that if they use 22/7 to represent pi, it gives them kind of an accurate value for some few decimal places. And so we always see that we represent pi as 22/7. But remember, pi is not 22/7. Don't forget, they are not the same. But approximately, we can equate them. Okay, and observe that your 22/7, okay, 22/7, look at the decimal of that. It repeats 3.14287, 142,857, 142,857, 142,857, 142,857. So it repeats, and that makes it a rational number. Okay, so we can't say that irrational number is equal to rational number. No, 22/7 is a rational number. Pi is an irrational number, but we can approximate. So that is why we always say take pi to be 22/7, so we can represent it. Somebody did something wonderful. He tried to generate more digits for pi, and he did the first 1,000 digits of pi, and you can imagine how wonderful pi can be. No repetition, no terminating. It will continue on and on and on. Right. So in a nutshell, the definition for the word pi is a mathematical constant, which is the ratio of circle circumference to its diameter, and it is represented by the Greek letter pi. So this is a letter in Greek alphabet, pi. So we can say pi is circumference over diameter, because we divided circumference over diameter. So if this is true, then we can come up with this relation, that if pi is equals to c over d, that is circumference over diameter, and we try to make c the subject, we do cross multiplication. So 1 will multiply c to give us c, pi will multiply d to give us pi d. We also know that anytime we have a circle and we have a diameter, the diameter is made up of 2 radii. Okay, that's a radius here and a radius, so 2 radii. So if that is the case, then we can say d is equals to 2r. Beautiful, because here is r, here is r, together gives us the diameter. So if I substitute this into d, then I can write c is equals to 2 pi r, which means if I want to know the circumference of a circle and I know the radius of that circle, I can use this relationship to find the circumference of that circle. If I want halfway through, then I divide everything here by 2. So this is how we find circumference of a circle using the constant pi when r is given. In our next video, we are going to solve more questions using this concept. Thanks for watching.